Fundamental problem F12-9 says the particle travels along a straight track such that its position is described by the ST graph. Then we're asked to construct the VT graph for the same time interval. And so as you can see, we are given the ST graph here, which is, of course, position S in meters versus time t in seconds. And for this curved section here, we have a function s equals 0.5 t cubed. Then on the right, s is constant with a position of simply 108. And that is on the time interval from 6 seconds to 10. And the curved section is, of course, from 0 to 6 seconds. And now going back to the problem statement here, of course, we want to find the VT graph from this ST graph. And so the VT graph is just simply velocity versus time. And so basically, since we're given position, we want to relate velocity v to position s. And so how exactly can we do this? Well, from calculus, we know that velocity v is essentially the derivative of position s with respect to time t, which is written as v equals ds by dt. And so what this tells us is that if we want to obtain velocity, we should just take the derivative of position with respect to time. So hence for our first velocity, we can take the derivative of the function of s, which is 0.5 t cubed. So doing the derivative, we multiply 3 times 0.5, which is 1.5. And then subtract 1 from 3, which simply gives us 1.5 t squared. So as you can see, we have obtained an equation that describes our velocity from our original position equation. But keep in mind that this velocity is only valid for the time interval from 0 to 6 seconds, which is also the same interval as the original position equation. And now to determine the velocity for the second time interval from 6 to 10, we notice that our position is constant at just 108 meters, which means that velocity is simply 0, since the derivative of a constant is always 0. And just to understand this more intuitively, if you have a particle or an object that is at the same position throughout a certain amount of time, that of course implies that it is not moving since it remains at the same position. So therefore, if it's not moving, it cannot have a velocity. So now that we have described the velocities at both time intervals, we are now ready to construct our VT graph. So I'll go ahead and put my coordinate plane here. In the vertical axis, we have velocity, which we can write as meters per second. And on the horizontal axis, of course, we have time t in seconds. And then I'll go ahead and just write down the times 6 and 10. And now all we need to do for our first velocity is define it at time t equals 6, just so we know the velocity at that time. And so substituting in 6 for t, we have 1.5 times 6 squared, which is 54 meters per second. And so I'll write down this 54 meters per second mark on the vertical axis. And since this function is quadratic, we can assume another curved graph, which will go up all the way until the 54 meters per second at t equals 6, just like so. And then of course, from t equals 6 to 10, velocity is 0. So this completes the velocity versus time graph of the particle. If you found this video helpful, please leave a like and subscribe for more.